One, go. Alright, so our lab is the effects of pH on the activity and activities. The effects of pH on the enzyme activity. Our abstract. Now, enzymes are substrate produced by living organisms that act as a catalyst to bring about a type of biochemical reaction. They are protein that help speed up the rate of biochemical reaction by lowering the activity energy needed to do this reaction. Without enzyme, living creatures will probably die because they won't have enough energy to get from their food that they eat. Now, trypsin is an enzyme which specializes in digestion, helping living organisms digest molecules which they need for energy. Now, most animals get their trypsin from their pancreas, but other bacteria usually secrete trypsin. Trypsin um, categorize trypsin digests protein by catalyzing hydrolysis, hydrolysis or proton bonds on the covalent side of the enzyme of amino acids like lysine or gynin. Our question that we are trying to find out is our question that we're trying to study is what pH is trypsin most active. We hypothesize that pH 9 will be the optimal level of pH for enzyme activity for trypsin because of the fact that normally human pancreas is a pH of 9. Alright, so our instructions come from the lab manual and it follows that we have 450 microliter of reaction buffer, 500 microliter of the acetyl casein, and the acetyl casein is a milk protein that contains sulfide that which allow us to view the absorption of the enzyme at 440 nanometers. After that, we had trypsin that we need to have 50 microliters, yes, and 500 microliter of a 10% TCA. Now, TCA stop enzyme activity, enzyme reaction, plus help, I would say, plus help separate from what they're digesting so that we can actually see the enzyme and not like seeing the enzyme plus what they're digesting. It helps separate so we just get the enzyme. Because we were testing the enzyme activity at different pHs, we had the buffer between pH 8 to 11. First, we set up everything by getting the spectrophotometer and the centrifuge warm up. We filled 3 centrifuge tube with 450 microliter of reaction buffer, then 500 microliter of the acetyl casein for every pH. We labeled the pHs group A to B, and you can see how it relates because you have you have pH 8, 9, 10, and 11. So we have A, B, C, D. Now, then we filled 3 more centrifuge tube in the same way. We added 50 microliter of deionized water and labeled each of them pH group A prime to D prime. Now the prime group A prime to D prime are going to be our control variable in a way that it will have 0 enzyme activity. And that's why we didn't add any enzymes and we just added the water. Now all the samples after they were done was frozen over the weekend. So we had to heat them up, return, and put them in 37 Celsius over the course of 10 minutes in a draft bath. Then we added 50 microliters of the trypsin to sample A to D to get an accurate negative group we needed to zero the enzyme activity and remove the enzyme activity and replace it with water, like I said before. Then we place all the sample in a 37 dry bath again for 20 minutes. Now, the reason why we kept this condition is because we wanted to make sure that both enzymes are in the same situation. I mean, both samples are in the same situation, but one had enzyme and one didn't. And the condition is supposed to match the pancreas of a human being. Okay, so so step 5. Add the 500 microliters of TCA solution and centrifuge our sample for 2 minutes at 14,000 RPM. So the 14,000 is about 14,000 RPM for the centrifuge because the centrifuge changed sometime. This removed the remaining substrate that was not affected by the enzyme. We blank our cuvette of diamine water was prepared to zero out the spectrophotometer at 440 nitro meters. Step 6. After 2 minutes, sample group A to D were removed from the centrifuge and the enzyme activity was measured and recorded in the spectrophotometer, while sample group A to D primes, A prime to D prime, was centrifuged for a constant negative control. A prime to D prime were put through the same condition as our experimental group, and the experimental group is A to D. Remember, it's to keep them all in the same place, and so that we can say that, okay, if there are any changes, the changes will be the enzyme activity due because of pH and not due to any other factors. After that, you have step 7. After 2 more minutes, the enzyme activity of the sample group A prime to D prime were recorded and measured in the same way as A to D. Now we have about 3 replicates for each primes for each of the solution. So if you add them all together, you should have like 24, because you would say 4 times 3 equal 12 times 2, and you get the 2 from experiment group A to D, and sample group, negative control group A prime to D prime. Therefore, there should be 24. Now the reason why we have this range is, number one, to have the range. The reason why we have the ability to have the range to take down the outliers and to also put down the good accuracy and precision into our sample, into our data, because you don't want a data that is all the way out there and they're not in the same range and average together. Okay, so we get our averages and we collected them for each of the solutions tested. Now the highest absorption record recorded was pH 9 for the experimental group. Comparing pH 9 to all the other pHs, we didn't have a big difference. Definitely when it came to comparing pH 9 to 8, there were like 70% difference, and it wasn't big enough or significant enough to say, okay, so there is a difference between pH 8 and 9. So all our experimental group were compared to the references or the negative control group, and all was found significantly different. And the reason, now let me explain this. So what I'm trying to say is that when you compare the negative control group to the experiment group, there was a difference. The experiment group showed that there were enzyme activities. The negative control group, like A prime and D prime, showed that there were little to no enzyme activity. And you can see that in our graph, our table. Now, remember, when blue is the experiment group, A, B, C, D. Red is negative control group, and those are our keys. Negative control group is A prime to D prime. And we have the title, absorption, experiment, and control group. We have the absorption here, and we have the pHs here. Now, you can see that, like I say, that between comparing pH 8 and pH 9, they're no different, but comparing pH 9 to pH 10 and 11, there was a humongous difference. And our little tab here compared the data between the pHs and the pHs of 8. Therefore, there was little to no difference between the pHs of 8 and the pH 11. There was little to no difference in the pH 11 in the experiment group, saying that we had a good accuracy, overall accuracy inside our experiment. The only problem with our accuracy that I can say is probably experiment 10, pH 10 will have a big range of variables, and that probably could be an error, and we could have shorted it down and fixed that somehow. But that is what my data is trying to tell you. Now remember, all this is done in a 37 Celsius temperature. One accent. Okay, so in our t-test table, we have pH 8 to 9 test experiment group and negative control group. Now pH, comparing pH 9 to every pHs, pH 8 show that they have a 0.054 difference in between pH 9 to pH 8. pH 8. We didn't do pH 9 because we can't compare them to each other. pH 10 compared to pH 9 have a smaller than 0.05, and that's the same thing for pH 11 compared to pH 11 when pH 9 is compared to it with less than 0.05. The control group as well have less than 0.05, but that should be concluded because we wanted to make sure that the control group had no enzyme activities. Now the thing that we can fix here is to add in the other pHs 7, 6, and 5 to give us a better idea that is the pH 8 and 9 the best optimal level for enzyme activity. Go. Alright, so in conclusion, our experiment does not support our hypothesis that 9 the optimal active enzyme activity level. The reason for it is because we do not have 6, 7, and 5 to say that 9 is the optimal level for enzyme activity, as well as that our data showed that enzyme activity was optimal between pH 8 and pH 9. All we can say is that pH that hits 10 and up would not have an optimal level for enzyme activity. Now, when compared to group that had the pH, we're doing also a pH experiment, we couldn't compare all groups together because their pH experiment would have an error, and we can't compare all group to a experiment that have a possible error, because therefore the data could be masking, or it could be messing up both of our facts or data. And also, what we could do better in the future is probably set our temperature to 48 to 68 Celsius. And the way we got that number from is we got it from the other two groups that were doing temperatures, and we asked them what temperatures were the best in their opinion to see the most enzyme activity, and we got that type of range. What else the other thing we can do in the future is probably put them all together, put our samples all together. And when I mean all together, I don't mean A to B all in the same group and all together in a bowl. I'm trying to say that after we centrifuge and get all the pulp out, so it doesn't mess up our absorption and don't mess up our reading, we combine the samples together, like all the A samples, go to combine together, so we can get a good range of the A sample group, and all the A prime can combine together and combine them together to become a good idea of the sample group that A prime have. Now, in my opinion, the reason why we didn't do this is probably because we didn't want to introduce an error into our experiment, and we didn't want to have anything that we can say that, oh, this is a possibility that why we went wrong. Could we combine something, then separated something? Because there could be a chance that one of the sample had something wrong with it, and that was an error, and all the other sample was okay. But the moment we added that error to the other samples, it contaminated the rest of the samples. So for bacteria, the main growth, the main condition that could be best for them is 48 to 68 Celsius temperature and around 8 to 9 for pH. That's it. And this is our sources.